Hello class, today we are looking at functions and function notation. The first thing we have to do is to define what a function is. So the essential question is, how do I identify functions? Learning intention. I'm learning to identify functions and use function notation. Warm-up. You're going to simplify. You've got two warm-ups. Simplify the first one, graph the second one. Please pause the video and see if you can do that now. Well, I do hope you did it on your own and you are ready to just check your answers. So if I'm looking at this is simplifying, but it means I've got to distribute. Not only am I distributing, what I'm distributing are decimals. So 3.5 times x is just simply 3.5x minus 3.5 times 2. Okay, here's my decimal. 2 times 5 is 0. Carry the 1. Bring your decimal down. 2 times 3 is 6, plus 1 more is 7. So this is 7.0. I would not need the 0.0, but I am going to leave it. Okay, so plus 8.5 times 2. 2 times 5 is 10. Carry the 1. Bring your decimal down. 2 times 8 is 16, plus 1 is 17. And now, 8.5 times negative 3 is going to give me a negative number, so I'll put the negative down. 8.5 times 3, 3 times 5 is 15, carry the 1, bring the 5 down, carry the 1. Bring your decimal down. 3 times 8 is 24, plus 1 more is 25. Okay, so I have distributed. Now I need to gather my like terms. I've got two x terms, and I've got two numbers. I'm going to rearrange 3.5x plus 17.0x minus 7.0 minus 25.5. Now I'm ready to finish. 3.5 plus 17.0 is 20.5, followed by your x. These are both negatives, so I combine them with addition. 25 plus 7 would give me 32, and it'll be 0 plus 0.5 is 0.5, and we're done. Okay, do you remember how to graph your equations? This is in the form y equals mx plus b. B is where you begin. M is how you move. So I'm going to begin at 5. And this is actually 0, 5. I'm going to move down to right 3. So Where's that bring me down to? Down 1, 2. Right, 1, 2, 3. Now I can draw my line and I'll be done. Okay, and this brings us into the topic for today. What is a relation and what is a function? A relation is any pairing of inputs and outputs. So anytime you've got sets of numbers that go to each other, then that would be a relation. So all I have to do is have any x and y's, have a set of them, and I look at them. Anytime they're paired up, that is a relation. Now a function is a very special type of relation. A function is a relation in which each input is paired with exactly one output. Now your inputs are usually your x values. So your input is paired with exactly one output. Now your output, we have been calling it y, but now we're going to call it f of x, g of x, something with x. So we're going to identify this, the set of points as a relation or a function. Remember, we focus on the x values. So as I'm looking, I've got -3, 2, -2, 8, 5, and 7. X does not repeat. It's only paired with one output, so this is a relation, or a function. Okay, let's look at the next one. -2, 8, -2. My -2 repeats. -2 is mapped to 0. -2 is mapped to 5. I've got 8, -8, 5, and -7. So the rest are okay, but it's a relation. Because -2 is mapped to 0 and -2 is mapped to 5. So when your x's repeat, that means the x is mapped to two different outputs. And that means that it is a relation instead of a function. Okay, explain why each mapping is or is not a function. So to be a function, it should only have one line from each of the first numbers. These are your inputs, these are your outputs. 1 goes to -1, 3 goes to 4, 5 also goes to 4, and 7 goes to 6. But do the inputs go to two different numbers? No. So this is a function. Because each input is paired with only one output. Okay, let's look at the next one. We've got 3 goes to -2, 1 goes to 0, but 0 goes to -1 and 0. Because 0 is mapped with two different numbers, it is a relationship instead of a function. It's a relation because 0 is mapped to -1 and 0 is mapped to 0. That little arrow means is mapped to. Okay, so remember that that arrow means it's mapped to. So it's mapped to two different numbers. It goes to two different outputs. It is not a function, but it is a relation. Okay, so we've looked at coordinate points and sets of them. We've looked at the mappings. Now, let's look at what happens with graphs. There is a test called the vertical line test. If any vertical lines drawn intersect the graph at only one spot, 1 point, the graph is a function. Remember which way is a vertical line? It's straight up and straight down. Okay, if any vertical line intersects the graph at only 1 point, then the graph is a function. So let's look at these vertical lines. As I go through here, this one only intersects at 1 point. This one only intersects at 1 point. This one intersects at 2 points. That means it is not a function. But what about the second graph? It only intersects at one spot, so this is a function. It's a function because it passes that vertical line test. Okay, we've looked at coordinate points. We've looked at mappings. We've looked at graphs. So the last thing we look at is a table. Is this table a function or a relation? Explain. What are we looking at? Which values do we have to have that cannot repeat? The x value. So I'm focusing on my x values. -2, 0, 6, 9, 3, 1, 0. I have 2 zeros. That means it is not a function, but it is a relation. Zero is mapped to 6, and 0 is mapped to 12. How do you know you're successful? You know you're successful when you can identify relations and functions. So this is relations versus functions.